Okay. Hello, everyone. So, thank you for a nice introduction. Now I will talk about a little bit different things, because today you will hear a lot about coding, about what to use, which framework, what to choose for your new project, for existing project. But you know, I never see any project, no matter how small or big, without storing that it stores some data. So now I will tell you a little bit about how to choose the place where to store, how to store your data. So first, a little bit talk about myself. So I'm a Google developer expert for web and cloud. So I really like doing things for people and for selecting best practices for cloud computing. So first of all, what is data? This is quite generic question, and it's very important to understand what data is before choosing the place where to store and how to store. So, generic definition of data is just sequence of some data that, or some symbols or bytes, bits, no matter, that has a specific meaning or interpretation. So data by themselves, it means nothing until you try to interpret this, to understand what it is. So, and I would like to show a couple of really good quotes, and they are my favorite quote. It's, you know, actually it's author Arthur Conan Doyle, but who said this? Which character? Yeah, it was Sherlock Holmes. He said that it's a capital, really serious mistake to do any thoughts, create any series before you have a data. Another quote that I really like is a quote from a good scientist. It's Deming, and he said that we can trust in God, but for everything else we need to bring a data. So data is crucial for any application. It's very important to select the right place and the right way how to store this data. And from my experience as a consultant, I know that some companies, even big companies, make a huge mistake of selecting incorrect storage, incorrect way. For example, for sequential data, for events that happen over time, they select a relational database. That's very illogical. So they spend a lot of money, a lot of developers' time and efforts try to feed their data in wrong structures, in wrong place. And that is why it's really important to understand this. So, how we can store the data? To answer this question, we need to understand what is the shape of your data. So, what is the structure of it? In a Google Cloud, there are plenty of different options to store the data. There are a small subset of that that I'm planning to talk, and it looks like there are a lot of, and they're completely different. So choosing the right, seems like a quite complex problem. To make it simpler and to let you make a right decision, I will try to go step by step about investigating what the type of data you can store. So the first question that you should ask, what is the structure? Do you have any information about the structure of data? But of course, first you need to understand what is the structure of data. So the structure is the arrangement or some inner information about this data. Do you have this information? In the first step, let's assume that we don't know anything about the data. So data is a completely mystery for us, I mean, format of this. In this case, the best solution is to use some blob storage or something that you can store just a set sequence of bytes, bits, or blocks into the cloud, and you don't care about what is inside. For this, the best option is to use a Google Cloud Storage. The cloud storage, it's just basically blob storage that you can store any block, any, for example, images, videos. Videos could be different format. It could be motion JPEG, or it could be AVI, or any other things. So you just put it there, and that's all. After that, you have a durable storage, so you don't have to care about what happens if your hard drive dies or a computer dies. Also, it is high available, so you can bring this data to the closest regions where your user are. It's scalable, so you don't need to care about where to create and how to create new instances to serve this data. And of course, it's quite consistent. If you put some image, you can be sure that it is exactly what you put there. So it's a quite obvious storage in a case if you don't have any information about that. And the most interesting that when people come to the cloud computing, they say, oh, it's quite complex to write the code for the cloud. It's quite difficult to store the data. And I would say it's not true. Basically, it's one screen of code that allows you to put any file into Google Cloud. That's all. You don't need any additional code. You just install Google Cloud /storage package in a Node. This is example in Node.js, but all SDKs available in a Java, C#, Python, Go, and whatever. Make code smaller, I decided to use mainly Node.js. So here you can see that all we need is create client for Google Storage and upload file there. Simple. And that's all. After that, this file is available in different regions, it's durable, scalable, and so on. So let's go further. What if we know something about data? So in a blob storage and in blobs, you don't know anything. But sometimes you have some insight about the data. For example, you can say that there is some entity with the different fields on it that I can enumerate, and these fields are certain type. For this, if you have some basic information, what could be, but it's not strict. For example, some entities have 5 properties, other entities have 1,000 properties. The best solution in this case is to use a BigTable. Actually, this product is heavily used in Google for different purposes, including Google Search, one of the key products in Google. What it is a really high performance, as you can see, the Google Search, Gmail, other products works really fast. There's no SQL, so there's no direct relations with them. And the good thing that we have a consistent row latency, so it's no matter how many rows you have. Actually, you can have a really petabytes of data stored in a BigTable, and you have the same latency that 100 rows. Also, you can easily add new columns, remove columns. Actually, there's a source code for that, so we mostly it's Java, as I see. Again, very simple. We just create a table, because BigTable obviously works with a table. We add some column names and just put it there. As you see, BigTable works very good with values are basically data, bytes. That's what I mean when you say something I know about data. So it's like an advanced version of storage because it allows you to put some columns. Interesting about the columns. You probably get used for the relational databases where you have some limited number of columns. In a BigTable, there could be thousands of columns. Small example how Google uses a BigTable. Each document, each HTML document that's been indexed in Google has one row in a BigTable. And each link, for example, that exists in this document has a column family type of anchor and has a different columns in it. So, of course, different documents has a different number of links inside of this. That's for a big table, it's no problem. So one row, you have one column of some certain column family, and other can have 1,000 of columns. That's really great. For a big table, they don't care. You have a consistent latency. You can have really billions of the records of different types. But what if we just don't need only to store the data, but we want to have some analytical information about it, to have some prediction about it? What will be, or what was the most popular article in the last 10 years in Wikipedia? Or if we want to have number of users in a GitHub that use some specific language, and so on. So we have a leak, let's assume that we have a really big amount of data, and we want to analyze. We can put in a big table, but querying all these billions of data could be really hard. For this purpose, there is a BigQuery, another Google product that used heavily in a case if you do want some predictions on your data to analyze and have some financial consequences. For example, analyze the best times when your product is being used by your users. In this case, you can use BigQuery. It's a really good thing because you can have enterprise data warehouses for your application without need to invest a lot of money in data centers and where to store. Again, it could be used for very small projects with several thousand of records, up to petabytes. It's you pay as you go. So if you're a small user, you mostly pay nothing. If you're big companies, you should pay, but you will save a lot of money because you don't need to invest in infrastructure, in data scientists that organize your data. You just put data in a BigQuery and then create any kind of queries to get inside. Here's a small code that's utilized BigQuery. As you can see, I just connected BigQuery, write a SQL query. It looks like an absolutely normal SQL query that you can use for MySQL to MS SQL or other things. So, but there are some limitations of that, but still it's quite simple. And you run this query. This query can run for a couple of seconds in a case if you have petabytes or terabytes of data. But when it completes, you can have callback for that, and you can get all the results. Actually, interesting thing is that you can experiment in BigQuery, using BigQuery by utilizing some public data, like, for example, all articles in Wikipedia available to everyone. Just open BigQuery console and write data using public data sets. Also, information from GitHub about repositories and a lot of articles, and there are quite a lot of public data set that available to use a BigQuery. So you can play quite easy and for free with that. But quite often, when you create some sites, your data is hierarchical. So you have a good example of this is product catalog. You have, for example, you are writing the application for selling some items, and you have household items, computer items, electronics. Then in electronics you have notebooks, smartphones, home appliance. Within computer, PC, you can laptops, I don't know, tablets, or in the phones. So you have some hierarchical subset of data. For this ideal and the most efficient way to store this kind of data is to use a data store. It's a little bit strange way of storing because you need to start thinking in a hierarchical way. Basically, you can use it like a normal NoSQL, but in this case, you will not get all the benefits of using hierarchical data storage. But you still can use it for a system state, for example. You have top level, like your application. For your application, you have user states. For user states, they have some information, for example, basket in your shop, which this user done. Interesting that it is looks like quite NoSQL. It has a fully ACID property, so it's atomic, it's consistent, it's isolating, and durable. It has indexes, so for example, you can create an index and then later very easily query which products has price over $1,000 US, for example. And the good benefit is that it provides data types, so it stores data quite efficiently. You can have, for some property type of float pointing, for some measurements, or string and other things. It's really good comparable to a lot of other NoSQL databases where everything is a string, for example. Or here's a small example. In this example, I put such primitive entity like a task. So we are writing like a task manager. We have entity task with different properties in. We have a Boolean property, some strings, and I have creating a key. Key is the way how I can find this entity. So this task is for user alias, and this task is inside of a task list called default, and the name of the task is sample task. So it's basically like a path for the entity. This is the way how you construct keys are the way how you hierarchically construct your data. After that, if we have key and we have entity, we can easily put it inside of data store. And of course, you can easily get it. But you know, this way that you need to specify the path for the data or some properties looks a little bit strange and complex, because you need to, if later you decide to move into different paths, it becomes quite strange. So I would say the data store is really, really powerful, but it requires some mindset, and first you need to analyze data and to do a lot of assumptions. So it's used best for the bigger application. What if you want a very simple way of storing this type of data without thinking about the keys, about the indexes, about all those things? Here comes another great product called Firebase RealTime DB. This is a very simplistic way to store the data. Basically, in a majority of the application, your data looks like simple objects. For example, if you're using JavaScript, it looks like a simple JavaScript object. In Java, it's a pure Java object, and so on. So basically, it's just objects that you want to put somewhere. For this, Firebase is a really great solution. Here, it's still NoSQL, so there is no relation between entities. And you can store any JSON-like objects on any point of your hierarchy. So you can consider Firebase RealTime DB like a big JSON object that you can query any leaf of these JSON objects of this tree. Separately, you can change some subtree. You can get whole subtree or some whole tree or some small subtree inside of this. Good thing that you have SDKs for Android, for iOS, for web, for server-side SDKs. So you can have Android application where user can add some items, and they immediately are available in real time for all other applications on iOS or on the web. If you can easily, the most simple example of using Firebase, it's using to creating chats where users can add some chat messages and everyone receive. But of course, it could be not, you can share within same user or within same graph. It's really nice, and for small projects, for if you don't need petabytes scale system. As you can see, there's a small example where I create object with the name DevFest number of participants, and I just put it somewhere in my database. That's all. You don't need any advanced configurations or creating schemas or connecting and making sure that you have a stable connection with the database, receive all the updates. It is all done by SDK. And this SDK available, again, in native Android, native iOS, or web and server side. It's really great. But if you start using Firebase, DB, you understand that you often have the same type of objects putting the everything. If you're storing the set of your users, mostly all users have name, surname, some email, passwords, so all these entities are same. Of course, in a Firebase, you can put this, but you cannot utilize this for example, if you're using Java or C# or some more static languages, you can. It's hard to utilize that. All the objects have the same shape. And not so long ago, Google announced a new version of Firebase DB. It's like advanced, so you have everything what you had in a Firebase DB, but now there is a cloud Firestore. This is quite new product, but it's already stable. As I said, it's available all features like real-time updates, offline support, scaling, and everything is available for you. But what the biggest difference that if Firebase DB was JSON-oriented, Firestore is document-oriented. So documents is has the same shape, has some key values. Key are strings, values are different. It could be different type of object. It could be strings, it could be floats, it could be any binary data. So it's really handy. It looks like you have some collection and you have several documents inside of it. Interesting that these documents and this collection are still organized as some hierarchical feature. So basically, Cloud Firestore, it's a result of analyzing thousands of different applications, how this application use data. And this is typical configuration of mostly any project, any system that stores data. That's really good for again, for startups, for companies just want to start using some cloud storage and don't want to invest a lot of time into modeling this data to use a data store or BigTable. So here's an example again in Node.js. It looks quite similar to what you had in Firebase DB, but the difference that we have this document, it's a single entity in a Cloud Firestore. So, for example, if you put the same document in a Firebase DB, you can access object example as a separate entity. In a Firestore, it's a single entity, but you can have a relation to the other entities. So, basically, if you want to use, you have same type of the entities, like a doc data. Later, you can just simply put or set, insert, query, update, delete these entities in a Firestore. And it's quite easy to use. So what if your data is relational? What means relational? That is organized in tables. It's more like classic normalized data. So it's a quite common practice, and we have 1,000 developers and data engineers who already get used to think in this way of thinking. Actually, in a cloud, it's quite hard to have these relational things because the relational databases are, generally speaking, not scalable. And if you can avoid using a relational database, please try to avoid using it. Of course, but there are already thousands of projects, libraries that using MySQL, MS-SQL, and other things. For this, there is a Cloud SQL. Cloud SQL looks like, and it feels like MySQL or Postgres installed in the cloud. You can even use the same libraries to access this data. Internally, it's much more optimal. It's scalable, and it's a much more performance, and you have a lot of nice things like instant backups, restores, and you have really nice way of management. But interesting, for a program, for API point of view, it looks like normal Postgres or MySQL databases. With some small limitation, but interesting that you can have a node with 200 gigabytes of memory. Okay, so but what if we started with a small projects and MySQL was good, we moved to the cloud, but then we became really popular, our project became popular, and we need to scale. What I mean by scale? I mean really scale. When you need thousands of nodes. Some here. But interesting, in this case, as I said, relational databases are really not recommended. So you need to pick what to be a consistent data, so each write is synchronized with the thousands of nodes if you have scaled. Or in this case, you have low performance. Or you want to be eventual consistency, that you write in some nodes, and later in some time it's distributed another. So it's like you need to select one fast or scalable or what. But interesting thing, you don't need to choose anymore. Now there is a Google Cloud Spanner. For me, when I read about the spanner and I first get information a bit, I was so excited. It's so different. Basically, what the difference, what is really special about Spanner? Cloud Spanner is not software, just software solution. It's a combination of software and hardware. Google invented a special devices for synchronization between nodes, between different, very distant locations. Theoretically, you can have a spanner node even in the moon or in the Mars, and you have still what you have as the result. You have a relational data with the schemas, defined schemas. It is the axis, again, so it's atomic, consistent, isolated, and durable. It has transaction, distributed transaction. Just imagine you can have a distributed transaction between Ukraine and Mars. Okay, no problem. Before announcing Spanner, this problem was absolutely unsolvable. With the Cloud Spanner, now it is. And when I said scaling, what I mean that you can scale not with, you can horizontally scale within single region from 1 to thousands of instances. You can scale and shard between different regions. For example, you can store data for Ukrainian users somewhere closer to Europe, and for United States users somewhere in the United States and west on East Coast. And everything is done automatically, maintains. And still you have less, I wrote 10 milliseconds, but Spanner claims to be 1-digit millisecond latency. So basically, in average, getting the data, not transferring to you, but reading data and analyzing the request, it's less than 10 milliseconds. It's really great. And 5.9 availability. That means that's mostly everywhere, every time. And also it has a SDK for a lot of platforms. So though it's not compatible to general MySQL or Postgres libraries, but still there are a lot of SDKs available for everyone. And of course, you can write application. One application could be written in a C# or Java, and other use the same data in some other SDKs. And interesting that it is very easy to use. Why? Because you have SQL compatibility level or SQL 99. So it's you write normal SQL queries as you get used for MySQL or MS SQL. But as a result, you get all the scalability, sharding, latency, and all these really fancy things. So I would say that for relational database, there is no any other option from any other company that provides the same functionality, just because, as I said, it's a combination of software and hardware. So I think the available option, what I just listed, I had only 40 minutes. It's absolutely not enough to talk deeply about all those things. But at least now, I hope you're able to select the best product for your data, depending on how you would like to store. And I will give a very short recap of the options and I will try to structure it, put it in from less structured data, so from data that you have mostly no inside of it, and up to highly structured when you can define the schema of your data beforehand. So what we have? We have cloud storage. It's for binary data that you don't know, like images, videos, and so on. After that, we have a BigTable. It's rows with mostly unlimited or big set of attributes that can be grouped into different column families. Then it goes the BigQuery that allows you to put some data and later very fast analyze thousands. You can put, for example, logs from your system, from Apache or other things, and then make a BigQuery, like which were most frequent requests and so on. Then it goes data store. It's a hierarchical NoSQL database. Then it goes Firebase DB, RealTime DB, when you can just put JSON objects there. Then goes Firestore. It's a document-based real-time database with the possibility to use it from different mobile or web and server-side applications. Then goes Cloud SQL. It's like MS SQL, or MySQL, Postgres, but in the cloud. Then goes Google Spanner. It's like a relational database, but with a highly available, with a great sharding and with a complete SQL 99 support. So basically, that's it. All slides are available online on this link. Also, you can find some information about me and contact me in a case if you have any questions or you would like to get more information about using any Google technology from web or cloud. Thank you very much. I hope you enjoyed, and it will be useful.